Welcome back to the King Air Autothrottle video series. By now, you should have a thorough understanding of the normal and abnormal modes of the King Air Autothrottle. You should know what autothrottle mode pairs with each vertical flight director mode. We'll now apply that knowledge to a normal flight scenario, seeing how the autothrottle will transition through a full flight from takeoff to landing. Our primary focus will be to showcase how the autopilot and autothrottle work together to assist you with maintaining the aircraft's flight path. This will be a great test of your mental model. If you're able to anticipate the autothrottle modes and predict the autothrottle's response to changing vertical modes, then you have a strong foundation for your operation of the King Air Autothrottle.
Before we dive into our scenario, take a moment to review the table for the autothrottle and vertical flight director modes. Consider printing this table to refer to as we walk through our scenario. We'll be flying from Dallas Love Field to Will Rodgers International. Our cleared route is the Texoma 5 departure, Zema transition, then the Tisdale 3 arrival. Our filed cruise altitude is flight level 220. During our pre-flight, we'll review the flight plan FMS en route page and set our desired climb, cruise, and descent schedules. For this flight, we'll choose to fly the default climb and descent schedules and set normal power cruise for the cruise schedule. To follow the automation in our scenario, we'll keep the AFCS status and the autothrottle mode annunciator at the top of the screen. We'll also show a vertical profile of the flight to keep track of our progress. To set up our automation, we'll verify the speed source switch is set to FMS. The speed reference is our climb schedule speed, and the altitude selected is per ATC clearance. We'll press the Go Around button and confirm we see Takeoff in the AFCS status box. To arm the autothrottle for takeoff, we'll press the AT key and verify we see a white AT takeoff in the autothrottle mode annunciator. For our takeoff clearance, we're told turn left, heading 050, climb and maintain 5,000. Prior to taxiing onto the runway, we'll verify our heading bug is 050 and our altitude bug is set to 5,000. We'll taxi onto the runway and advance the power levers for takeoff. When torque on both engines is greater than 1,000 foot-pounds, AT takeoff becomes active and moves the power levers forward, targeting max power of 2,230 foot-pounds. When AT takeoff becomes active, the pilot should follow the throttles with their hand in case there's a need to abort the takeoff. During the initial climb, the yaw damper can be engaged. Above 400 feet AGL, the pilot can select the desired lateral and vertical modes and engage the autopilot. For the lateral mode, we'll select heading and follow the flight director to 050. For vertical guidance, we'll select FLC to perform a constant airspeed climb. Because the speed selector is set to FMS, our climb schedule speed of 170 knots will be targeted. The autothrottle will transition to AT climb and set climb power, while the flight director will pitch for 170 knots. After verifying our lateral and vertical modes, we can engage the autopilot. We can also bring the props back to 1900 RPM for the climb. This should be done slowly and smoothly to avoid over-torquing the engines and allow the autothrottle to adjust the power levers as the RPM changes. As we're climbing out, Tower tells us to contact departure. After we check in, departure instructs us to turn left, heading 360, and maintain 5,000 feet for traffic. We'll set our heading bug to 360 and verify expected autopilot response. Upon leveling off at 5,000 feet, the vertical mode will change from FLC to ALTS, and then to ALT, to hold 5,000 feet. The autothrottle will transition from AT climb to AT normal cruise. Note that for certain software versions, you'll see AT speed during ALTS. To ensure that we don't exceed the speed limit of 200 knots below the Class Bravo airspace, we'll change our speed source switch from FMS to manual. When that happens, AT normal cruise will transition to AT speed, and the manual speed bug will appear on the airspeed tape at our current airspeed. We'll move the bug to 200 knots using the speed knob, and the autothrottle will manage engine power to maintain the selected airspeed. Now ATC calls and tells us to proceed direct to Bleco, climb and maintain flight level 220. We'll handle the lateral navigation first by setting direct to Bleco and pressing nav. For the climb, we'll raise the altitude bug to flight level 220 and press FLC for the climb. The autothrottle will transition to AT climb and move the power levers forward to maximum climb power. It will maintain our manually selected 200 knot airspeed for the climb. To adjust the speed, we can manually dial a lower speed or move the speed source switch back to FMS to track our climb schedule speed of 170 knots. For now, we'll keep the speed selector in manual and set a manual speed reference of 170 knots. Upon reaching flight level 220 and leveling off, the autothrottle will transition from AT climb to AT speed and maintain our selected manual speed reference of 170 knots. To follow our FMS cruise schedule, we'll change the speed source switch to FMS and see the autothrottle transition to AT normal cruise. The autothrottle will set normal cruise power based on the performance tables for 1800 RPM at our selected altitude. After about 15 minutes in cruise, we begin to approach the top of descent. We hear ATC tell us that we're cleared to descend via the Tisdale 3 arrival, and that Will Rodgers is landing runways 17 right and left. We'll verify we have the correct transition selected for our arrival in the flight plan, then set up VNAV by lowering the altitude selector to the bottom altitude on the arrival of 6,000 and arming VNAV. Upon reaching the top of descent, the autopilot will capture and follow the VNAV path. The autothrottle will transition to AT speed and target our descent speed schedule since our speed source selector switch is in FMS. Keep in mind, if there are speed constraints on the arrival, you must switch to manual mode and manually set those speeds. Since the arrival has high speed constraints, it's likely ATC will vector us off, which is exactly what happens here. ATC tells us to fly a heading of 340, descend, and maintain 10,000. We'll set our heading bug to 340, select heading as our lateral mode, and set our altitude selector to comply with the ATC instruction. Because we're off the VNAV path, we can select either vertical speed or FLC to continue our descent, and turn VNAV off to prevent an intermediate level off at 11,000 feet. The autothrottle will maintain AT speed and continue to target our descent speed schedule. Upon reaching 10,000, the autopilot will transition to altitude hold, and the autothrottle will transition back to our cruise schedule, AT normal cruise. Our next instruction from ATC is to turn to heading 360, descend and maintain 4,000. Expect the ILS 17 left. We adjust the heading bug to 360, set our altitude bug to 4,000 feet, and select either vertical speed or FLC to start our descent. The autothrottle transitions to AT speed and targets our descent speed schedule.
Note that the autothrottle will only bring the throttles back to about 450 foot-pounds to keep the blades out of flat pitch. If a steeper descent or quicker deceleration is desired, you may need to disconnect the autothrottle and manually control the power levers.
Prior to level off at 4,000, we'll change our speed bug from FMS to manual. The autothrottle will stay in AT speed. The speed bug will change from magenta to cyan and track our current airspeed. From this point, we can manually control our speed as we descend on the approach. When we dial in a lower speed, the autothrottle will reduce power to decelerate at about 1 knot per second. As we level off at 4,000, the autothrottle will stay in AT speed and adjust power to maintain our selected speed. As we come around downwind, base, and final, we can continue to dial our speed down using the speed knob. When the autopilot intercepts the glide slope, the autothrottle will maintain AT speed and target the selected speed in the approach to the runway. In the event we need to perform a go-around, we can press the toggle button on the power levers. The autopilot will transition to go-around mode and pitch for the climb, while the autothrottle will transition to AT takeoff, providing maximum power for the climb. Both the autopilot and autothrottle will remain coupled. If all goes well during the approach and we choose to land, the autothrottle will transition to AT idle as the aircraft crosses through 45 feet AGL, and smoothly reduce both power levers to idle. About 2 to 5 seconds after sensing weight on wheels, it will automatically disconnect, leaving the power levers at the idle stop.
We hope this video gave you a chance to exercise your knowledge of the King Air Autothrottle. If at any point you were unclear on how the autothrottle would transition, Go back and review the Modes and Enunciations video. Still have a question? Reach out to us at aviation.training@garmin.com. Make sure your mental model is accurate before flying the autothrottle, and thanks for flying Garmin.